Hello everyone, I'm Prashant Mahajan from All India Sri Shivaji Memorial Society's Institute of Information Technology, Department of Electrical Engineering. In this video, we'll take a look at interfacing of LED with PIC microcontroller. LED is a light emitting diode. It's a semiconductor device which emits lights which emit light when a current flows through it. So it has two terminals, one is anode, second is cathode. So when you forward bias this LED, um, then it emits light. You need to use a current limiting resistor in series with the diode to limit the current. So there are different configurations in which you can connect the LED with the microcontroller. The different configurations are common cathode configuration and common anode configuration. Now in common cathode configuration, as you can see, the diodes, all the cathodes are connected together and they are grounded, and the anodes are connected to the ports of PIC microcontroller or any microcontroller. So if you want to switch on these LEDs, you have to make the lines of port B equal to 1. So if you make these lines equal to 1, the LEDs will glow. Now to configure or to switch on the LEDs, first you need to configure port B as an output port. So to configure port B as an output port, the register which is used is TRIS register, TRISB. So when you clear TRISB register, the port B will be configured as output port, and then you can send the data. So these are the two lines of codes which will switch on all the LEDs connected to port B. So CLRF TRSB will configure port B as output port, and SETF port B will set all the bits of port B, and which in turn will switch on all the LEDs. Here, here all 8 bits of port B are used. So if you want to connect only single LED, then that can be done using only one line. So to switch on this particular LED, you need to switch on this particular bit, which is an RB1 bit in this case. So you can configure only this bit as an output bit. So to do that, you have to use an instruction bit clear file trisb, 1, 0. So BCF instruction is a bit level instruction and has a general format as BCF F, B, A. So B is the bit that you want to set, okay, or you want to clear. So this instruction will clear the first bit of TRISB register. Therefore, RB1 will be configured as an output port, and then the second instruction bit set file port B, 1, 0 will set this particular bit, which in turn will switch on the LED connected to this particular bit. The register used over here is for limiting the current through the LED. So this is a common cathode configuration which we have seen. Now we'll take a look at the common anode configuration. Now this is a common anode configuration, and as we can see, all the anodes of all the LEDs are connected together and that tied to plus VCC. Now to switch on the LED, the bits of port B need to be made equal to 0 so that the LED is forward biased and the LED will start glowing in that case. Resistors are used for again limiting the current through the LED. Again, you have to configure port B as an output port because you need to make all the bits equal to 0. So that is done using CL, RF, TRISB. So this will configure port B as output port. And now in this case, if you want to switch on all the LEDs, you need to clear the bits of port B. So CLRF port B will clear the port B, and which in turn will switch on all the LEDs connected to the port B. Okay, so only have one register, sorry, one LED which is connected to any port, a port bit. Then you can configure only that particular bit as an output bit. So if say RB0 bit is used for an LED, so you can make that particular bit as configure that particular bit as output bit using an instruction BCF PRISB comma 0 comma 0. So it will configure RB0 as output bit, and then you can switch on that particular LED using an instruction PCF bit clear file port B comma 0 comma 0. So this is the way in which you can individually say switch on an LED. So these are the two configurations and the assembly language programs associated with it. Thank you.